dignitaries, delegates, and members. Okay. At the outside, I thank IPTA for providing opportunity to talk and present the paper. First of all, I want to introduce my company. My company is Banknote Paper Mill India Private Limited. It's a joint venture of Printing Minting Corporation of India Limited and Banknote Paper Mill India Private Limited. It is a joint venture of Finance Ministry as well as RBI. It has been set up in the year of 2016. The capacity is 12,000 metric ton per annum. We have achieved 133% of efficiency. Yes. In the process of preparing the green manufacturing in the paper industries, so I wanted to present two projects which we have already done successfully. It is working. The concept was that in our pulp effluent, the effluent temperature is about 70 to 75 degree temperature, which the biological treatment of the ETP, due to which the biological treatment of the ETP is severely affected. The waste heat from pulp mill effluent can be recovered and used as a boiler makeup water and to cater the hot water requirement of the paper mill to reduce the process steam requirement. And the second one is the air compressor, heat recovery from the air compressor. The oil in the air compressor system get heated up to 100 degrees centigrade, as everybody knows it, and the same is being cooled after cooler to bring down the temperature. Instead of rejecting that heat to the surroundings, the oil, the thermal energy is being transferred to the condensate water. The temperature of the condensate can be enhanced from 65 degree to 85 degree. Thereby, the additional steam requirement for the heating condensate water can be reduced. This is what, so when the concept has come, from the concept to design, design to procurement to installation, commissioning, and successful running is a very big challenge. We had this requirement in our plant, hot water requirement. The base temperature is 60 degree, and it will be different temperature about 60 degree being used in different places. However, the base temperature is 60 degree. Till that project has been implemented, we are using the steam to heat up the water to the hot water requirement of the entire plant. Existing supply network is kept intact. Additional heat requirement, if any, and above the 60 degree can be fulfilled by using the steam. That means we kept that our existing system where the steam is being supplied to that for heating the water, kept intact. The pulp mill effluent contains a lot of, in the process, though the temperature is having the effluent, there is a lot of fibers and other dirt will be there. So we wanted to remove first before feeding into that, to the heat exchangers. The about, for that purpose, we have used that, your screen, vibrating screen you are used, where that, effluent is being fed to the vibrating screen. From there, the solids and the liquid is being separated. The separated liquid having the temperature about 70 degree temperature is being passed through that heat exchanger. About 160 meter cube of water per day, the process water is being heated up to the about 60 degree. That means the effluent is having the 70 degree temperature. We have transferred that about 60 degree of the temperature to the process water from ambient to 60 degree. That is being supplied to the plant to cater that hot water requirement of the plant. Thereby, for supplying the 160 meter cube of water per day, we have reduced about 8,000 kgs of steam on regular basis. And the heat recovery from the compressor system. As you know, everybody, in the compressor, the 20%, 80% of the energy is lost in the form of heat, and only 20% is being utilized for the work done. So we thought of that how to utilize this. Instead of cooling that oil and dissipating the heat to the surrounding, why don't we use this heat? The concept has come. Then we thought of, because in the first stage, whatever the recovery we have done, we have covered entire plant requirement of the hot water. So we have thought that there is no any other water. Then it has come to our this thing. Why don't we, whatever the condensate we are getting, it's about 60 to 65 degree temperature. Why don't you increase the temperature above whatever the temperature we are going to get it? So we have installed a compressor with a heat recovery system, where we are passing the entire condensate water through the heat exchanger, in which we could able to enhance the temperature from 65 to 85 degree temperature. In the process, we have reduced another 5,000 kgs of the steam. Total steam reduction in both the project is about 13 kg per day. It is 30 ton per day. This is the process. We have we have installed that spiral heat exchanger for that pulp mill, because plate heat exchanger will not work in that, because it is a high viscosity and effluent having that lot of TSS. There is a possibility of choking that system. That's why we opted for that spiral heat exchanger. And also the plate thickness is very high in the spiral heat exchanger, and efficiency also more compared to that plate heat exchanger. Whereas in that compressor system, we have installed plate heat exchanger. This is the process. Yeah, you can see that the graph. This was the total steam generation per kg. This is the, we have done 5 days trial. In that we have stopped our heat recovery system. Then we have seen that the total heat, the steam generation is about 17,000 per day, which has been reduced to 1,70,000 per day. The steam reduction has been reduced to 1,56,000. And total FO consumption without heat recovery system, it is about 12,771. Whereas with the heat recovery system, we could able to reduce to 11,713. The almost 1,000 kgs of FO we started saving on regular basis. This is our photograph of the heat recovery system. You can see, though I cannot point out that printer. Yeah, it has the effluent. The right side is our effluent pulp mill. From there, the effluent is coming, which has been fed to that spiral heat exchanger. The separated water is collected in a tank. Then it is pumped to the tower plant, wherever the hot water requirement is there. This project has been successfully completed in the 2020. And as I told, about 8 tons of steam on regular basis we are saving. And this is a photograph of heat recovery system. It is a really excellent this thing. We have recovered entire compressor cost within 8 months. Because every day we are feeding the more than 1,60,000 liters of the water, where the temperature of the water is being increased from 65 to 85 degree temperature. 20 degree temperature add up has been happened. So that has given very good result. Thereby, from this process also, we could able to reduce the steam consumption to about 5 tons per day. And see, these are whatever the saving and whatever that this thing is, that it's not a primary object of our this thing. But the temperature of the effluent is a 70-75 degree temperature, which is going to the ETP, where that my aeration, which enters the aeration tank, it is a 45 degree temperature. So that our biological treatment was severely affected. So we are not getting the desired COD, BOD after the completion of the treatment. We are forced to send back this water treated in the pulp stream, send back to the paper stream to treat further. This was the situation earlier. After implementing this, the temperature of the effluent in the aeration tank come down to 35, which is a conducive temperature for the biological treatment. So you can see that this was that we achieved. Earlier that you can say in that aeration tank it is a 45 degree temperature, has been reduced to 35 degree temperature. And initially the DO in the aeration tank was not rising more than 0.4 to 0.5. Now it has gone up to 1.4. And the treated COD, BOD, earlier the average COD we were getting is a 260 ppm. That has been reduced to 180 almost. So which is a permissible limit to discharge to that environment. Under the BOD also you can see earlier it was 60, that has been reduced to half. It has come down to 30. And the treated water TSS also come down, and treated water turbidity has come down to 70, 37 to 20. This is the main object of our entire project to do this. Because there is a, you know, that pollution control board norms where we have to, you know, we have to comply with a lot of things. Yeah, result. Yeah, trial was conducted over 5 days. By supplying the hot water to meet the plant requirement, about 8 tons of the steam we are saved. And by increasing the temperature in the concentrated water, 65 to 85 degree temperature, we could be able to save 5 tons of the steam every day. Overall, about 1,000 kgs of the, you know, furnace oil consumption was reduced with these projects. Average FO cost is about 50 rupees per kg. And in terms of financial, every day 50,000 rupees saving we have started realizing. And annually it will be 1.65 crores we are saving. Temperature of the effluent, as you told, that has been reduced to 35 degree, where that our treated water quality parameter has been enhanced like anything. And apart from that, it is a carbon footprint. Yeah, you know that FO generates almost 3.11 kgs of the carbon dioxide when it burns. Accordingly, about 1,100 metric ton of CO2 emission has been reduced annually. Apart from that, the huge SOx, NOx, and the combustion of the FO, you must be knowing that it generates the gases having the high potential for the ozone depletion and which have the global warming potential. Hence, by reducing the FO consumption, the reduction in the realized corresponding quantities of the combustion byproducts like CO2, NOx, and SAX, etc. was achieved. These are the project we have done. Apart from that, we have done a good things in water conservation also. Result of which we got a national award for the excellence in the water management from the CIE in 2021. And the last year, we have got a first prize in a best practice in the rainwater harvesting nationally. It is a good this thing. We are almost 10% of the water we are recovering from the rain. Thank you. Thank you.